Okay, the box problem. Oh, the box problem. Okay, follow with me. Stop me if you need it. Okay, the volume of said box should be length times width times height, or in this case, I guess that would be depth. Depth times width times height. Everybody agree with that? Okay. So if I were to look at this, I'm saying that the width and the depth, based on the problem, the width and the depth will, hold on. Oh, square base. So the width and the depth will be the same. Both of those are going to be x. We're going to denote that as x. We're saying that they're the same length. Okay, so the base is a square. Now I'm going to leave the height as is. In part 1, it says express the height in centimeters as a function of the width, and then state the applied domain. So all I'm going to do is I'm going to isolate h. So would you agree that I could say x times x is x squared? Okay. So could I say that volume divided by x squared would equal the height? We do. We do have a number for the volume. The volume is always going to be what? 1,000. So I could, hello, there we go. I could plug in that constant. So I could say that the height in terms of x would be 1,000 over whatever x squared is. That's h of x. That's expressing the height as a function of the width. That's done. Now let's state the applied domain. What would not make sense for a value for x? 0 or anything less than 0, right? But I could increase x as far as I want to. So what would be an applied domain for that? From 0 to what? Yeah, infinity. All right, so that would be a good applied domain. Part 2. It says solve h of x greater than or equal to x. Okay, so if h of x is greater than or equal to x, what is h of x equal? Well, that's 1,000 over x squared. I want to know where that's greater than or equal to x. Ideas of what we should do there. Guess and check. Oh, you children, you. You guessed and checked, you child. What I'm going to do is multiply by x squared on both sides, Luca, you bad kid. Okay, so that's going to cancel this and this. So I'll get 1,000 is greater than or equal to x to the third. Oh, 1,000, you're a perfect cube. So what does x have to be less than or equal to? 10, because 10 cubed is 1,000. Oh, okay, cool. So let's interpret this. What does this mean? In order for the height to be larger than what? The width. X must be less than or equal to 10. If it exceeds 10, then the height will no longer be larger than the width. If it exceeds 10. Because 10 would mean that it's a perfect cube, right? Then the box is 10 by 10 by 10. So it'd be a cubic box with a volume of 1,000. Okay, now let's have a little conversation about this piece. I'm going to write out the height function in terms of x, as we already know. Let's interpret this behavior. What would happen to h of x if x approached 0? Let's say x got really small, right? The box starts to get smaller at the base. What would have to change with the height? You have to get larger, right? So as x approaches 0, h of x would approach what? Infinity. So as x gets smaller, height would get larger. What if x got larger? Yeah, then h of x here, h of x would have to approach 0. Because what's constant is the volume. So if you change the variables on the base, the height has to change appropriately. Inversely. Oh, inverse relation. Inverse relationship. Okay. Express the surface area. Oh, gosh. Here we go. Okay. Let's talk surface area. Okay, so let's talk about the surface area of this box. I teach geometry, so I'm actually decent at these. Okay, this would be 1,000 over x squared. Okay, so let's consider just the surface area, the inside of the box. Remember when we had the problem where you did the box problem and we painted the inside so the children wouldn't know where they were? So we painted the inside black so the kids were like scared. Remember that? Oh yeah, ignore that. That was just a problem we thought about. Okay, so I'm going to have how many of these surfaces? If I'm painting just the inside, I don't have 2. How many do I have? 4, right? Because isn't this the same size as that? Right? So I'm going to have 4 of those. What would the dimensions of that be? X times what? 1,000 over x squared. I'd have 4 of those. And then what would the area of the bottom be? X squared, good. So this is how we'd write out the surface area. The surface area in terms of x. So let's distribute and just be good kids about this, be varsity. Because most of the time I'm JV. What would this reduce to? 4 times what? Yeah, the x and the x squared would just make an x in the denominator. So that'd be 1,000 over x plus x squared. So I could go further and have 4,000 over x plus x squared. Cool? Pretty good? We okay? So how would I find a domain for that? A reasonable domain for x. Well, I know it can't equal what? 0, right? Eddie, what do you think? You have thoughts beyond can't equal 0? Okay. Are there any restrictions on what x could be other than non-negative and not 0? Under 10? Now, I don't know that we need the same restrictions. We're not worried in this problem whether or not height is greater than x. All we're worried about is that we don't get some non-real answer or negative answer, right? So it can be anything. X can be anything. Now in part 5, it says use your calculator to approximate 2 decimal places, the dimensions of the box, which will minimize the surface area. So I'm going to go off cam here. Is that right language? Off cam? Am I going to go off the grid? No? Burning your social security number. For you children on the web, we just finished talking about going off the grid. I want you to type this function into your calculator and come back and you'll see a visual of ours. And we're going to do part 5 together. Be right back. All right, hey kids on the web, we typed into our function here 4,000 over x plus x squared. We graphed it. We're about to find the min value. 3 is our option. So we press second trace, and we want a left bound, so we want some point to the left of that min. You can be really close. We want a right bound. You can be as close as you want to as long as you're not to the left of it. And then press enter one more time. And there we go. If x is 12.6, we will minimize the surface area. If x is 12.6, we will minimize the surface area. So our answer for part 5 would be if x is approximately 12.6, is it inches? Centimeters, we will minimize surface area. Like, subscribe, comment below.